Welcome, friends. Let's find some limits using this two-variable function, 2xy over x squared plus y squared. So first is do the following limit. Say y is equal to x. What does that even mean? In the picture, what it means is this. This y equals x is like a line in the xy plane, and you're going to travel along that line, and you see that the values of the function are the ones up here along the surface, and they seem to be approaching this value right there. That's about a value of 1. That's what the picture seems to be saying, first of all, that this is 1. Let's actually work it out. So we're going to have the following. Along y equals x is going to be f of x, comma, and because y is x, you put x in here. And then you create your expression 2x times another x over the x squared. Then you replace y with x. So it's going to be x squared again. Then you end up with 2x squared. We're multiplying in the numerator. And then you divide that by x squared plus x squared, which is 2x squared. So the x squared parts will cancel off and you end up with just 1. Again, this assumes, of course, that here x is not equal to 0. So we get 1. So in limit form, I would say something like f of x comma y approaches 1 as x comma y. So x comma y are the points in the xy plane. So you're going along this line towards the origin. So you would say you're going to approach the origin 0 comma 0 like this. And then something like along y equals x, that line. So that's done. Now look at the second. It's the same picture, same graph. It's just been tilted. Let's say y will be equal to 0. Now what does it mean to say y is equal to 0? So in the picture, it amounts to saying that we're going to travel here this way towards the origin along the x-axis, because along the x-axis y is equal to 0. It's right there where the black line is located that I've just drawn. F of x, and then you're going to just write here comma 0. So f of x comma 0, y equals 0. You're going to have 2x 0, and this will be here over x squared plus 0 squared. And then you work through that, so it's going to be in the numerator there 0, and the denominator is just going to be x squared, which is of course just 0. Again, assuming of course x is not equal to 0 because it's a different story. So here what you would say is the following in terms of a limit statement. F of x comma y tends towards 0 as the point x comma y approaches the origin again. So in the picture, remember, you're going along the x-axis, you're still going towards the origin. So as x comma y approaches 0 comma 0 this way, along y equals 0, or along the x-axis. That's another way to describe it. Let's also do one, we're going to travel along the y-axis, where I'm drawing towards the origin. So we're going to say x is equal to 0 along the y-axis, and then f of x comma y. So now because x is 0, put 0 in this position, and this is going to be 2 times 0 times y over 0 squared plus y squared. And this is going to give you numerator 0 and the denominator y squared, but that's just 0. Of course, this assumes y does not equal to 0. So what we will say then is f of x comma y tends towards 0 as the point x comma y tends towards the origin. So again, we're moving along the y-axis. All those points are going towards the origin. So you got to say 0 comma 0, and then something like along x equals 0, which is in other words expressed by saying along the y-axis. Now, since these limits are different, this is 0 and this is 0, and this first limit was 1, what we would say is the following then, that the overall limit does not exist. So the limit as x comma y here approaches 0 comma 0 of f of x comma y, you would say is d and e does not exist. That's how you would express that as a summary statement. Just leave a like.